We are moving down in the arm now, or distal in the arm, to muscles of the forearm and wrist and hand. And so we've already seen this subsection, muscles that move the radius and ulna. We touched on this at the end of last class, the biceps and triceps brachii. As we move distal into the forearm, there are still muscles that move the radius and ulna that mainly arise in the forearm. And that's why I'm bringing this back up again. I'm not showing brachialis and brachioradialis. Those are the major muscles that would be considered in this group, because you've seen those in lab. But I want to highlight that muscles that move the radius and ulna do not only flex and extend. They do not only flex and extend. They also pronate and supinate. So we're going to look at some of those muscles, the unsung heroes of the forearm. And the first of those is pronator teres. Pronator teres. As its name would suggest, it pronates the forearm. How does it do that? We'll get a better sense of that when we look at origin and insertion. And I want to show, or bring to light now, the idea that most muscles on the anterior side of the forearm are innervated by the median nerve. And pronator teres is no exception. It's mostly on the anterior surface of the forearm. All the flexors of the digits and the wrist that we're going to talk about on the anterior surface are also innervated by the median nerve. So this is one that we'll come back to a fair bit. Anterior surface of the forearm, median nerve, the second M in the MMU of the brachial plexus. And this has a somewhat complicated origin and insertion. There are 2 points of origin for this muscle and 1 insertion across from the medial side to the lateral side of the forearm. And what that allows us to do is, when that muscle shortens in contraction, to bring the lateral side of the forearm more medial, to pronate the forearm. And so the 2 origins are the medial epicondyle. You can feel that bump on your elbow, the epicondyle, that process above the condylar surface of the humerus on the medial side. And the coronoid process of the ulna. We've talked about that a fair bit at length. So it spans the elbow joint and then inserts on the radius, specifically the lateral surface of the radius. Now, I took the time before class to take a few screenshots that highlight and illustrate these points a little bit better. You can see the 2 origins shown here clearly. Medial epicondyle at the top, the coronoid process, no surprise, and you can imagine it extending across to the lateral surface of the radius. And then as that muscle shortens and contracts, it would bring the radius over, pivot the radius on top of the ulna, or pronate the forearm. So I have a series of images like this that I'm hoping will illustrate the position and placement of these muscles, because as we get back to the textbook images, as focused and detailed and small as they are, it's hard to imagine the path of some of the muscles and nerves and blood vessels. Incidentally, I've taken the focus of the artery supply out completely for this section, so don't even worry about arteries for the forearm and wrist. What else pronates the forearm? Anything with pronator in the name. Pronator quadratus. Pronator quadratus spans both the ulna and the radius, and it's a quadrilateral shape, roughly square or rectangular, hence the name pronator quadratus. If I asked you what nerve innervated pronator quadratus, being in the anterior compartment of the forearm, what would you say? Who wants to take a guess? Who's brave? Yeah? Fantastic. Median nerve. Nice job. Paying attention. I like that. Median nerve. Anterior compartment of the forearm. And pronator quadratus essentially just spans the most distal parts of the radius and the ulna. The most distal parts. And it's perpendicular to the bones, if that makes sense. It contracts across the radius and the ulna in order to pronate the forearm. You can see that example highlighted here. The distal anterior surfaces of both forearm bones. You connect these 2 points, you contract and shorten the muscle, and you bring the radius over top of the ulna to pronate the wrist. Very straightforward. And these are the main muscles that pronate the forearm. So what about their antagonists? We're looking at one antagonist. One muscle that supinates, that does the opposite action. And it is conveniently named supinator. Not difficult to remember the name of the muscle that supinates the forearm. Supinator. Very straightforward. Supinator is one of potentially the exceptions. It doesn't only reside in the anterior compartment, so it doesn't break our rule necessarily of the median nerve innervating most of the anterior muscles. It wraps around the radius on the lateral side, and being that it wraps around the radius, maybe it makes sense that it follows suit. It's innervated by the radial nerve. Innervated by the radial nerve. It's hard to capture the origin and insertion all in one image. I have two that are going to come up to show you how it wraps around the radius. And it would need to, if you think about the job of supinating the forearm, you'd have to wrap around the radius to connect to the ulna at the back in order to shorten in contraction and open those two bones. So, point of attachment 1, or origin 1, lateral epicondyle, the bump on the outside of the elbow, and the lateral surface of the ulna, which is kind of odd to think about, right? The ulna is the medial forearm bone. It's most inward. And you can feel the back of the ulna just on your forearm now. And supinator originates from the lateral surface of the ulna. So the ulna is the medial bone on the lateral surface of the ulna. So right about here. The radius is more lateral. It's on this side. At the lateral surface of the ulna. And it wraps all the way around to insert on what I'm calling the anterolateral surface of the proximal third of the radius. Anterior and lateral surface. So let's take a look at what that looks like. This is the right arm. You can see the ulna clearly. The olecranon is obvious. You can see the lateral epicondyle. That's the direction that we're looking. We're looking from the outside towards the midline. Two origins. The epicondyle here. And this is the lateral surface of the ulna. The lateral surface of the ulna. Wrapping all the way around the outside of the forearm, around the outside of the radius, which is shown here. It inserts on the anterior and lateral surface of the radius. all the way around the outside. So you can imagine when those 2 points are drawn together in contraction, that opens up the forearm. And those are the muscles that we are going to focus on that supinate and pronate the forearms. From there we move to the wrist. From there we move to the wrist. We move to the wrist and forearm and digits. Matt's already illustrated to you that many of the muscles that move the fingers and the thumb originate in the forearm. They don't originate in the hand. We are going to look at one that does originate in the hand, the strongest of the muscles of the intrinsic hand. But a lot of them originate from the forearm. And I want to take a brief minute to outline some of the terminology that we're going to see. It's a mishmash of these terms. So you'll see flexor and extensor, and that's a no-brainer, the action of the muscle. Flexor and extensor. Incidentally, there are anterior and posterior compartments, which correspond to flexors and extensors. And there are also superficial and deep levels in each of those compartments. There are a lot of small distinctions and different muscles to look at. We're not looking at all of them though. But just be aware there are different levels to the hierarchy. Whenever you see something referring to pollicis or referring to the pollix, it means thumb. Pollicis means thumb. And the complementary term for fingers is digitorum, referring to the digits, referring to the fingers. And this should be intuitive, but I'm laying it out here for you so there's no confusion. What's maybe not so intuitive, if you see the word carpi, that refers to the carpus, which is Latin essentially for wrist. Any muscles with carpi in the name will often attach to the wrist bones, or as we know them, the carpal bones. And you know the names of all 8 carpal bones. Stop letting those people touch the cadaver's hand. Carpi is a muscle that attaches to the carpal bones, or the wrist bones. And metacarpals. I have that written here. Carpals and metacarpals. If you see longus or brevis, it's not the length of the muscle plus tendon, it's just the belly of the muscle. There are some very long brevises. And they're so named because the muscle belly is short or small. The tendons might be very long, but the belly is short. The contractile part of the muscle is short. So longus versus brevis means long versus short muscle belly. And then you'll often see radialis or ulnaris. And that doesn't necessarily mean they attach to the radius and the ulna. And it doesn't necessarily mean that they're innervated by the radial nerve or the ulnar nerve. The best division that I can give you is that it refers to the side of the forearm where the muscle resides. The radial or lateral side, the ulnar or medial side. There are some examples that, never mind, we'll leave it at that. The side of the arm. It will be more clear as we go through examples. So let's start with flexors. We are looking at 3 major flexors. 1 superficial, 1 deep, and 1 for the pollicis. Probably the most obvious flexor, Flexor Digitorum Superficialis. By surface area, one of the largest flexors on the anterior compartment, and being in the anterior compartment, innervated by the median nerve. This is a fairly widespread muscle belly. Originates at 3 different locations. Medial epicondyle, coronoid process, and the superior anterior half of the radius. So radius, the proximal anterior surface, anterior half of the radius. So I'll bring this up to show you those 3 attachment points. I think you can see them fairly nicely. We have medial epicondyle, coronoid process of the ulna, and on the other side of the forearm, the proximal anterior top half surface of the radius. All of those points connect through one tendon, move through the wrist, and insert on the digits, the body of the middle phalanges. And you know, if I just said that, body of the middle phalanges, that this muscle does not insert on the thumb. We don't have a middle phalanx on the thumb. Middle phalanges, only the 4 digits. And so this is a prime contributor to my ability to flex my 4 fingers. Flexor Digitorum Superficialis. There is also a profundus, which just means deep. Flexor Digitorum profundus, but we're not going to look at that in depth. This is our digital flexor. If we can flex the digits, we haven't yet addressed how the thumb is flexed. The thumb, the pollicis, is mainly flexed by Flexor Pollicis longus. Flexor Pollicis longus. Anterior compartment of the forearm, median nerve. You've written that down already before I even revealed that info. And this muscle is essentially tucked right underneath Flexor Digitorum Superficialis. It's right under the muscle we just talked about. It originates from the radius, just underneath and distal to the top half of the radius, and inserts on the distal phalanx of the thumb. There's no middle phalanx on the distal phalanx of the thumb. So you can imagine this is still the anterior surface of the radius. Now looking at the left hand, you can imagine Flexor Digitorum Superficialis would be right over top. It would originate just on this superior border and then travel down superficial to this muscle through the flexor retinaculum and insert on the digits. It would be right on top of the Flexor Pollicis. There is a Flexor Pollicis brevis. I'm not going to show it to you, but the difference would be the muscle belly is a lot shorter. Longus, this is a long muscle belly. Brevis, it's much shorter. Now, I'm switching images. This is looking at the back, but still technically in the anterior compartment is the flexor Carpi Ulnaris. It's technically in the anterior compartment. It's superficial and anterior, but it's also in the medial compartment. It's the meaty part of your forearm. If you feel the medial side, it's the meaty part of your forearm. Meaty, medial, maybe that's just coincidence. It's technically the superficial anterior compartment, but it wraps around the medial side, and so it's not only the median nerve, it's not only in the anterior compartment. It doesn't break our rule. But wrapping around the medial side of the forearm, the ulnar side of the forearm, it's innervated by the ulnar nerve. Flexor Carpi Ulnaris. So this is probably attaching to one of the wrist bones. It acts to flex, and it's on the ulnar side. Very large muscle belly. If you feel your forearm, that's what you're feeling on the medial side. So it also arises, we've seen a few of these muscles, from the medial epicondyle. And this is medial. This is the right arm posterior view. So the body of the skeleton's over here. This is the medial side. And the posterior and medial aspects of the ulna. Here's a slightly different view. So the bone closest to you looking at this screen is the ulna. You can see the muscle arising from the posterior aspect of the ulna. Maybe even the medial aspect of the ulna. There's the medial epicondyle. And it inserts on a carpal bone, specifically on the pisiform bone. Which you can palpate yourself right now. You can feel the tendon coming off of pisiform. A little hard nodule in your wrist, a tendon coming off, is this muscle, Flexor Carpi Ulnaris. Now I also bring this up too, I heard a few of you talking in lab about the funny bone. This is the funny bone. So this is the ulnar nerve that you can see innervating Flexor Carpi Ulnaris. It wraps around the medial epicondyle. And when you bang your elbow against a desk, computer, something, you are activating, depolarizing, or irritating this nerve. It's very exposed in this area. So that's it for the pseudo-anterior compartment. Posterior compartment, where the extensors live, we're really focusing on one major extensor. The main extensor. Extensor Digitorum, period. Extensor Digitorum. No easy memory device for Extensor Digitorum's innervation, just the radial nerve. And it arises from lateral epicondyle through the extensor retinaculum to the distal phalanges. Lateral epicondyle down the back of the arm, back of the forearm, through the extensor retinaculum, and you can see that nicely here to the distal phalanges. Not the only extensor of the digits or of the wrist, but the only one that we care about. This is our candidate for extensors of the wrist and digits. Extensor Digitorum, Flexor Carpi Ulnaris. You see that pathway nicely illustrated here. Now notice the retinaculum encircles the tendons, anchors and secures the tendons to provide a pivot point, essentially. It doesn't show that when you look at the carpal tunnel or through a section of the wrist. It looks as though the retinaculum is deep to the tendons on the back side, or the extensor tendons on the back of the forearm. It's not the case. It does encircle the tendons on the dorsum of the wrist. And I brought this up just to show you, we talked about the carpal tunnel already. These are the tendons of Flexor Digitorum Superficialis, which we looked at. All the number 2s. I alluded to the profundus, the deeper version of that muscle. All the number 3s. We brought up Flexor Pollicis longus. Number 4, all of those tendons crammed into the tight confines of the carpal tunnel with the median nerve. And this is what is irritated, that causes that numbness, that tingling, that pain, if you have or develop carpal tunnel syndrome. So the retinaculum should secure and wrap around the entire wrist like a watch band to secure those tendons. And we see somewhat of a busier picture that highlights the same idea here, a view up the forearm, looking from an inferior aspect, looking up the forearm, all the tendons of the flexor muscles. You can see the median nerve highlighted there. One muscle in the hand that I want to look at, the strongest intrinsic muscle of the hand, and then we are done with our discussion of the upper limb. Obviously, it's not the only intrinsic muscle of the hand. There are many. You can see them here. And this is only the superficial layer. There are deep muscles in the hand as well. Generally, the muscles of the hand are grouped into 3 regions. So everything you're looking at here on the left-hand side, the ball of the thumb, so to speak, that meaty portion of the thumb, is the thenar eminence, T-H-E-N-A-R. That's one group of muscles. You would have seen it on the carpal tunnel slide as well. On the opposite side is the hypothenar eminence. And then everything else is an intermediate muscle between the two. 3 major groups. And the muscle of interest that we're looking at is in the thenar group of muscles that really allows for the opposable action of our thumb. The adductor pollicis. Adductor pollicis. This is the strongest muscle of the intrinsic hand muscles, innervated by the ulnar nerve, the U of the MMU. And it is what allows us to grasp and clamp things with our thumb, to press against the fingers of our hands. There are 2 parts to this muscle. You could almost argue there are 2 muscles. But instead, we say there are 2 heads. They insert at the same location. Essentially, there are 2 heads of adductor pollicis. It's very difficult to see it on this image. And this is what spurred me to take these screenshots for you. But if I remove all of those other overlaying muscles away, this is the adductor pollicis. In the left hand, you can see it arises from the base of the second metacarpal, the base of the the second and the third metacarpals, and the base of capitate as well. There's a little nucleus, you'll call it, or a little common point of origin. Second and third metacarpals, body of the third metacarpal, all the way to the proximal phalanx of the thumb. So both of these move across the thumb, across the bottom of the palm, and insert on the proximal phalanx. And it's because we have these varying degrees of muscle fibers that you can press your thumb independently across all 4 fingers. And you can feel it. You can really feel the adductor pollicis. You press against your index finger, it's a medium stake. You gradually move to the pinky finger, Well done. Well done. Medium rare, medium. No, medium and then medium rare. Got that backwards. A nice way to check the doneness of your steaks if you're barbecuing. Strongest intrinsic muscle of the hand. Really allows the opposable thumb to grasp and clamp, pick up things, use tools. Hey, maybe we end before the hour's up. We've covered a lot of material this week in class, this week in lab. Remember, we started with the pectoral girdle way back when. One bony attachment. The rest is secured by muscles to the axial skeleton. Girdle's made up of two bones, and his job is to connect the upper limb to the axial skeleton. Each upper limb has 30 bones. You can probably list all of them. You should be able to list all of them in three main locations or compartments. If you can't name all of them right now, they're listed for you here. Humerus, radius, ulna, carpals, metacarpals, phalanges. Names of the carpals you know as well. And without reiterating, way back we talked about the shoulder joint at length. That was our candidate joint in the upper limb. We did also discuss some aspects of the elbow, but we spent a bit more time talking about the shoulder. There are 9 muscles that cross the shoulder joint. 7 of them arise from the scapula to try to clamp those two together, the scapula and the humerus. 2 of them arose not from the scapula. Latissimus dorsi, pectoralis major. The only 2 that cross the shoulder joint that do not arise from the scapula. And then we spent much time over 2 classes outlining a summary table ad nauseum of the muscles of interest in the upper limb. We talked about 5 muscles in the pectoral girdle specifically. It's not that these are all of the muscles, but these are the ones that we talked about that we are concerned with and interested in. 5 at the girdle, 7 that move the humerus, 5 that move the forearm, including the supinators and pronators today. We just talked about 4 that move through the wrist and either flex or extend the digits and the wrist. And 1 in the hand, the Adductor Pollicis that we just talked about. So this is a nice summary sheet. If you can check off each of these bullet points in your own self-study and say, I know those, then you've got this section covered for the final. Any questions? Anterior compartment, median nerve. Other than that, that's it. That is not it. We have one quick announcement. Before you back up, with the internet being down, obviously we don't have access to Moodle.